Guys, welcome back to my channel. In today's class we'll discuss about chapter 6, squares and square roots. Okay, before starting exercise we'll discuss some properties of squares and square roots. Okay, what is the meaning of square? Square is a number obtained when a number multiplied by itself. Okay, if number 2, for example, we have 2, square of this number is 2 square means 4. Okay, this is the square of 2. Now all square numbers end with the 0, 1, 4, 5, 6 or 9. Okay, these are the numbers. Okay, all square numbers end with these numbers only. 0, 1, 4, 5, 6 or 9 will get in unit place of the squares. For example, 5 square is 25. Unit place number is 5. 6 square and 36 ends with the unit place number is 6. Okay, we have squares of a unit digit of a square is maybe 0 or 1, 4, 5, 6 or 9. Square root is the inverse operation of a square. Okay, inverse operation means 2 square means 4. Okay, its inverse. Square root of 4 means 2. Okay, square root is the inverse operation of square. Next, square numbers can only have even numbers of zeros at the end. Okay, square numbers 10 square is 100. Even number of zeros we have. If it is odd number, it is not a perfect square. 10,000, we have 4 zeros. Even number of zeros we have. 4 means even number. Even number of zeros we have, so it is a perfect square. Square of 100 is 10,000. Okay, if we have here 2 zeros, we will get 4 zeros in the squares. If we have 1 zero here in the square, we will have 2 zeros, double of this, 2 zeros. So square numbers can only have even number of zeros at the end. Okay, next, a number ending with 2, 3, 7 or 8 is never be a perfect square. 152 ends with 2, so it is not a perfect square. 1028, it's 8, so it's not a perfect square. 6593, whatever, if we have unit place digit 2, 3, 7 or 8, it's not a perfect square. Okay, 267, we have 7 in the unit place, so it's not a perfect square. Okay, a number ending with the 2, 3, 7 or 8 is never be a perfect square. Please keep in mind all these properties we are discussing now. so that you can easily solve the examples of exercises. Next, a number ending in 0, 1, 4, 5, 6 or 9 may not necessarily be a square number. If we have unit digit 0 means if we have 100, it's a square number. So square root of this is 10. In the same way we have 10 here. Okay, unit digit is 0, but it's not a perfect square. Okay, may not be necessarily the square number. Okay, it's not a perfect square. Okay, we have unit digit 0 here, but it's not a perfect square. In the same way, 121, we have unit digit 1. Square root of this is 11. Square of 11 is 121. But 11, we have unit digit 1, but it's not a perfect square. Okay, so it's not a perfect square. In the same way, a number ending with 0, 1, 4, 5, 6 or 9 may not necessarily be a square number. Okay, it's not necessary. If we have unit digit 0, 1 or 4 or 5 or 6 or 9, but compulsorily we must have these numbers in unit place after squares. Okay, for example, we have 5 square, 5 we have, so 5 compulsorily we must have these numbers, but all the numbers having unit digit these numbers means 0, 1, 4, 5, 6 or 9 may not necessarily be a square number. Okay, next property, square of even numbers is even. Okay, 2 is a even number. Square of this is 4, which is also even number. Okay, 4 is a even number. Square of this is 4 square means 16, which is also even number. Okay, this is one more property. Next, square of odd number is always odd only. Okay, 3 is an odd number. Square of this is 9, which is odd number. Okay, 5 square means 25, which is odd number. This is also odd number. Square of this also odd number. Okay, now next property is the difference of squares of two consecutive natural numbers is equal to their sum. Okay, the difference of squares of two consecutive, for example, consecutive numbers means 3 and 4. Okay, or 4 and 5, any 5 and 6, 6 and 7, 8, 9, 10, 11, 11, 12, so on. Okay, consecutive numbers. So the difference of squares means square of this 3 is 9, square of this 4 is 16. Difference of these squares is 16 minus 9 is equal to their sum, means 3 plus 4. 3 plus 4 is also 7. Okay, difference of squares of these numbers is equal to their sums. 3 plus 4 is equal to 7. Square of these two are 16 and 9. Difference between these two is also 7. Therefore, 4 square minus 3 square is equal to 3 plus 4. 16 minus 9 is equal to 7. 7 is equal to 7. Okay. This is also a property of squares and square roots. Next, a triplet means 3 numbers. For example, M, N, P. Okay, 3 natural numbers is called Pythagorean triplet if it satisfies m square plus n square is equal to p square. It is called Pythagorean triplet. Okay, for example, 3, 4 and 5 means 3 square plus 4 square is equal to 5 square. 3 square is 9 plus 4 square is 16 is equal to 5 square is 25. 16 plus 9 is 25, which is equal to 25. This is called Pythagorean triplet. This is also a property of squares. All properties of squares and square roots. Okay. Based on these properties, we'll solve the examples.